So we know for sure that we have a superheated pressure coming back to the compressor. It's a low temperature, low pressure superheated vapor coming back to the compressor. So the compressor takes that volume and squeezes it into a smaller area, and what happens is the temperature goes up and the pressure goes up together. So the temperature and the pressure goes up, but it's still a superheated vapor. Now it's a high temperature, high pressure superheated vapor. If you were to feel the suction line, it's going to feel cool to your touch. Even though it's a superheated vapor, it's low temperature and low pressure, so the heat's leaving your hand going into the refrigerant. If you're to touch the discharge line, it would literally burn you. It's going to be extremely hot. It's one of the hottest parts of the entire system. It's going to be a high temperature, high pressure, superheated vapor. It's still superheated vapor coming in and superheated vapor going out, but at this point, it's literally going to burn you. Now, over here, we were adding superheat, but now that we leave the compressor, we're going to be what we call desuperheating. So we're going to add that note over here, desuperheat. And we can literally measure this, so it's also going to be called sensible. It's going to be rejecting heat. So the temperature is going to be significantly higher than the saturation temperature. Heat's leaving this line right here, and in the first few fins of the condensing coil, it's actually rejecting heat. We're moving air across it, and the temperature is physically dropping. The idea is that we want to cool the refrigerant off enough to get it back to saturation, the point where it's going to condense, the point where it's going to change state. Up here, it cannot condense because it's too sensibly warm. It's above its saturation temperature. So we're going to sensibly and measurably cool off this refrigerant with the air and get it back to the saturation point. So it's still 100% vapor all through here, but it's superheated above its saturation point. Once we desuperheat it, sensible, measurable heat, down to saturation, then we can start condensing. Now the condensing temperature will be the same through most of this condensing coil because it's changing state from a liquid to a vapor. We cannot measure, we cannot see it. We just know that it's at its saturation point. We have an idea what's happening. We can't physically measure that, but it's rejecting massive amounts of heat through here. So desuperheating is a critical part. Now on the commercial side, we check superheat here as well, and there's a formula for it, which is the actual discharge line minus the liquid saturated temperature equals the superheated vapor on the high side. And residential, it's not as common. With the newer technologies, it's getting easier to do because we have wireless clamps we can stick inside of there. Most of the units we work with don't have that accessible, and a lot of people just leave that out. But it is still an important number. This discharge line, we want to make sure the temperature of this never exceeds 225 degrees Fahrenheit, whether it's commercial or residential. We want to keep this line under 225 degrees Fahrenheit. The reason is to keep the oil protected. What happens when we get above 225 here, it's going to be even hotter inside the compressor, and that's going to be where we have oil breakdown. The oil will get too hot and literally start coming apart, and that's going to cause That's going to cause a problem with our refrigeration cycle. So we want to make sure this temperature, this line temperature, never gets above 225 degrees Fahrenheit. There is a measurable superheat on there, but I want you to know that it does have to first desuperheat. And it's just the first little bit of that condensing coil desuperheating. So again, this is our discharge line. This is going to be the hottest part of the system. We want to make sure the temperature of this line never exceeds 225 to protect the oil inside. It's going to be even warmer. So this is the discharge. It's desuperheating. It's rejecting sensible heat. If you're to accidentally touch this line, it will burn you. This particular model has the discharge line exposed right here, easy to get to. But most of the systems, the compressor and the discharge line is inside of here. It's surrounded by the condensing coil. So it's desuperheating, rejecting heat all the way into the condensing coil, and just roughly the first little bit of this condensing coil is desuperheating. It only takes maybe a row or two of refrigerant lines. It very quickly dissipates heat. Overall, it's very little BTU. Now the rest of this is all going to be saturation, or the majority of this will be saturation.